potable water. Today's topic is potable water. What is the another name for potable water? What is the another name of potable water? So potable water, it is also known as drinking water. Okay. So it comes from surface and ground surface and is treated to levels that meet state and federal standards for consumption. And water from natural source is treated by microorganisms, bacteria, toxic chemicals, viruses, and fecal matter also. Okay. So potable water, it is generally we can use as drinking water. So these are the properties. So it should be clear, colorless, odorless. Odorless means no smell. Okay. It should be cool, pleasant taste, and it is harmful and suspended impurities. It should be free from dissolved gases like carbon dioxide, hydrogen sulfide, and ammonia. And it is a poisonous mineral like lead, arsenic, manganese, etc. And next, hardness should be less than 500 ppm, and chloride content should be less than 250 ppm. Fluoride content should be less than 1.5 ppm. Total dissolved solids be less than 500 ppm. And last one is pH of the potable water stand be 6.5 to 8.5. So these are the characteristics of potable water. Generally, we use for drinking purpose. Not only drinking purpose, we can use all domestic purpose and industrial sectors also. So that water should be clear, colorless, odorless. Okay, and it gives a pleasant taste. And the potable water contains some gases. Those are carbon dioxide, sulfur, hydrogen sulfide, ammonia, and some more poisonous minerals also dissolves into the water. Those are lead, arsenic, and manganese, etc. So we have to get the potable water. How we get the potable water? How we get potable water? Some steps involved. Some steps involved in treatment of potable water. So rivers and lakes are the most sources of water used by municipalities. These water should be free from colloidal impurities. These water should be free from colloidal impurities, domestic sewages, industrial effluents, and diseases producing bacteria. Hence, domestic supply of water involves following stages in the purification of process. So, I think you know river water and lake water, how it will be. It is a very cool and very. It appears very clear. Is it correct? Is it correct? In lake water or river water is clear or not? Say first. Anybody? Is it clear? No. So many dust particles and so many gases, bacteria, microorganisms. These all are dissolved into the lakes and rivers. So that's why we should not drink directly river water and lake water. So we have to do some purification methods. In that first one is a screening. In that first one is a screening. So in screening, it is a process of removing the floating materials like leaves, wood pieces, etc. From water. The raw water is allowed to pass through a screen having a large number of holes and retains the floating materials and allows the water to pass. First, we have to do screening. Okay, so in this step, we can observe the floating materials. We can observe floating materials. Those are leaves, wood pieces. That one we should remove by using screening effect. Okay, so you can this here. So this is a screening technique. So we have to place one mesh like a grills. So that drills, it is used to catch the floating materials. Those are leaves or wood pieces, any floating materials. It is stopped here. Okay. So and later uh, we have to remove the floating materials. And next step is aeration. Okay, aeration means we have to allow the gases. Okay, so in this process of mixing of water with air is known as aeration. The main process of aeration is to remove gases like carbon dioxide, hydrogen sulfide, and other volatile impurities causing bad taste and odor to water, and to remove the ferrous and manganese salts as insoluble ferric and magnetic salts. Okay, aeration means so already water contains different gases. Okay, some gases are useful and some gases are very harmful. Those harmful gases we have to remove. So that's why we have to do the aeration process. Aeration process, what do you observe? So we have to add some more gases to remove those harmful gases. So this is aeration process. So we have to this is the electric motor with propeller and slinger ring on vertical motor shaft. So it is a typical surface of aeration base. Note the ring floats are tethered to post on the basin. Okay, so we have to place the aeration, aeration machines. Okay, so in this aeration, what is the work of aeration machines? To remove the harmful gases. What are the harmful gases here? Hydrogen sulfide and carbon dioxide. Those harmful gases we have to remove. So by using aeration process. Next one is sedimentation. All know very well sedimentation. So it is a process of removing suspended impurities by allowing the water and undisturbed for 2 to 6 hours in a big tank. Most of the suspended particles settles down at the bottom due to the force of gravity, and they are removed. Sedimentation removes only 75% of the suspended impurities. Okay, sedimentation means where do you observe in sedimentation process? Anybody? Every day we observe in our home, in our kitchens also. We can observe sedimentation. So while cleaning rice grains, okay. So at that time we can observe the sedimentation process also. So we have to wait some time. So all solid particles settles at the bottom of the container. Same process here also. So removing suspended impurities by allowing the water stand, and we have to do undisturbed for 2 to 6 hours in a big tank. If you do disturb, so it doesn't we can't remove the suspended particles, solid particles. I mean dissolved solids also present like sand. Okay, so sand and some more particles also present. Okay, those solid particles we have to remove by using sedimentation. Okay, most of the suspended particles settle down at the bottom due to the force of gravity, and they are removed. Sedimentation removes only 75% of the suspended impurities. In sedimentation process, we have to remove only 75% of the suspended impurities. And next one is the coagulation. Finally, divided clay, silica, etc. do not settle down easily and hence cannot be removed by sedimentation. Such impurities are removed by coagulation method. Okay, so some more, just you removed only floating materials and harmful gases and some solid particles you removed. Okay, in coagulation process, we have to remove the some more chemicals. Okay, okay, So in sedimentation process, we just remove 75% of the waste materials and remaining 25% of the solid particles removing by using the coagulation method. Okay, finally divided clay, silica, etc., and do not settle down easily and hence cannot be removed by sedimentation. Such impurities are removed by coagulation method. Okay, so step by step we have to remove the impurities. Okay, so how we get potable water? How we get potable water? To do the some steps. What are those first step? Screening, and next one is, what is the next one?
Filtration.
Yes, and next one is sedimentation, and fourth one is coagulation.
Coagulation.
Okay, step by step we have to remove the waste particles. Okay, in this method certain chemicals called coagulants like alum. So alum, it is a chemical formula, it is very important. Al2SO4 thrice, etc. Like alum, Al2SO4 thrice, etc., are added water, it gets hydrolyzed to form gelatinous precipitate of OH3, aluminium hydroxide. These aluminium hydroxide entraps the finally divided and colloidal impurities settles to the bottom and can be removed easily. So we have to add the alum. So I think you can observe um, while doing pushkara snanas. Okay, so at the time every 2 hours they are added some like bleaching powder. Okay, so it is immediately kills the all germs. Okay, so many peoples are doing baths at that time. So many peoples released so many wastages. So that one we should remove by using the alum. Okay, so to kill the germs. So this is the coagulation process. Okay, coagulation and flocculation. So coagulant addition raw water in. So rapid mixing, slow mixing, rapid mixing. So in coagulation method also two types. So one is a rapid and another one is a slow mixing. Rapid mixing means very fast. Slow mix means slow only. Okay. So after coagulation process, allow the we have to allow the clarifier or sludge. Sludge means what is the state of sludge? Is it solid state or liquid state? Obviously, it is a solid state only. Okay. So later we have to. So this is residue and this is a filtrate. Okay. So after filtration, what we get? Filtrate and residue. Residue means it is a solid, and filtrate means um, floated water. Okay, so this is the filtration, treated water out. After coagulation and flocculation we get the filtrated water. So next step is the filtration only. It is the process of removing bacteria, color, taste, odor and suspended particles, etc., by passing the water through filter beds containing fine sand, quars sand and gravels. Okay, filtration process, you can observe this filtration bed. So first step is the screening and next one is coagulation, flocculation, sedimentation, filtration and disinfectant and water for distribution. So you can observe the filtration bed. So sand, gravels and some more big gravels are present. Okay, so through step by step the water is filtrated and later we get the water or drinking water. Okay, so it is by passing the water through filter beds containing fine sand, quars sand and gravels. Okay, fine sand means very small particles, and next quars, some big, and next one is gravels. I mean, step by step, the filtration bed also increases the sizes. the sizes are increased. Okay. And next step is sterilization or disinfection. In next step is sterilization or disinfection. The process of destroying the harmful bacteria tense. Okay, so two and three. Hello, who is two and three? Give me host. 213 ఎవరమ్మా? Okay, thank you. Okay, sterilization and disinfection. So in this process, we remove harmful bacteria. That process is called sterilization or disinfection. The chemicals used for the purpose is called disinfectants. Okay, this is final. First step is screening. What is the first step? How we get potable water? To do so many steps. Okay, what is the first step in that? First step, what is the first step? Screening. Okay, so what do you observe in screening? Anybody? So what is the first step in we get potable water? In first, what is the first step? Screening. What do you observe in screening? What do you observe in screening? To remove the floating materials. What are those floating materials? What are those floating materials? Say anyone. If you didn't say the answers, I will keep option for all. Okay. So next step is, what is the next step? So you have to say in your voice, through your voice. Just unmute and say, no problem. So next step is aeration. Aeration means, so what do you observe in aeration?
Removing gases like carbon dioxide
And hydrogen sulfide. So these gases are is harmful or useful?
Harmful.
Yes, that's why we have to do remove the harmful gases by using aeration process. And next step is what is the next?
Sedimentation.
Sedimentation. Where do you observe in our daily life? Sedimentation in our kitchens. Every day we observe. Okay. So while doing cleaning the raw rice. Okay. Rice ni clean చేసేటప్పుడు అబ్జర్వ్ చేస్తాం కదా. Okay. So sedimentation, the solid particles all settles at the bottom of the container. Okay. And some dust particles floats on the water. Okay. So in sedimentation, how much, what is the, how much percent we get, we can remove that waste?
75%.
Yes. So remaining 75% we have to remove. What is the next step? After sedimentation, what is the next step?
Coagulation.
Coagulation. And next step is a flocculation. Okay. And what is the final step? What is the final step?
Sterilization.
Sterilization or filtration? Sterilization or filtration? Filtration only. Okay. So the filtration bed, how it will be arranged? Filtration bed. So first the filtration bed is filled with gravel and later coarse sand and later sand, fine sand. Okay. So you can observe the picture. So this is gravel, coarse sand, and this is the fine sand. So through like this, we have to arrange the filtration bed. So this pipe through, we have to pass the water. So this bed, through this bed, the water floats. Okay. So finally we get the water. Okay. So disinfection and sterilization also removes the some harmful bacteria. Ozone. What is the formula of ozone? Anybody?
O3.
Yes, very nice. Ozone is a powerful disinfectant and readily absorbed by water. Ozone is a powerful oxidizing agent and kills the bacteria. Okay, and it is a very costly also. So it is easily kills the bacteria and it is a powerful oxidizing agent. So disadvantages already it is a very costly and be used in large scale. So we have to use only large scales only. So if you use a smaller amounts, so you get the more cost. Okay. So ozone is unstable and cannot be stored for long time. This is one more drawback for ozonization. Okay, ozone is a it is a very costly and we cannot store for long time. And next one is chlorination. The process of adding chlorine to water is called chlorination. It can be done by the following methods. Okay. So first one is chlorination. Just all know we have to allow the chlorine gas into the water. Okay. Chlorine gas can be bubbled in the water as a very good disinfectant. So here the reaction is chlorine reacts with water and forms the hydrochloric acid and hypochlorous acid. HOCl means hypochlorous acid. And next one is by adding chloramine. When chlorine and ammonia are mixed in the ratio 2:1, chlorine and ammonia. So a compound chlor is it is formed by the chloramine. Okay, 2:1 we have to add the ratio. It is first chlorine we have to take 2 moles, ammonia 1 mole. So a compound is called chloramine. So see, So chlorine reacts with ammonia to form the chloramine and hydrochloric acid. So here 2 moles of chlorine, 1 mole of ammonia reacted to form the Cl and H2. This is the chloramine and byproduct is the hydrochloric acid. Okay. And next chloramine react with the water molecule to form the hypochlorous acid. Again we get the ammonia. Chloramine compounds decompose slowly to give chlorine. It is a better disinfectant than chlorine. Chloramine gives good taste to the treated water. Okay, by doing chloramine method, we get the good taste. Okay, and moreover, it is a better disinfectant also. And next one is by adding bleaching powder. So when bleaching powder is added to water to produce the hypochlorous acid, a powerful germicide, a powerful germicide. So bleaching powder formula is CaOCl2. Okay. So CaOCl2 react with water molecule to form the calcium hydroxide and what is the byproduct? Chlorine. So again, Cl2 is reacted with water molecule to form the hydrochloric acid and hypochlorous acid. The hypochlorous acid, it is a very powerful germicide to kill the germs, microorganisms. Okay. So HOCl react with the bacteria. What we get final step? Bacteria are killed. Okay. So what is the today's class? What we discussed once again repeat. Anybody? Potable water. What is the another name of potable water? What is the another name of potable water? Anybody?
Drinking water.
Very good. So, what are the characteristics of potable water? What are the characteristics of potable water? What are the characteristics of potable water? Where do you use? To the team, give me host. Itansha. Okay, what are the characteristics of potable water? Anybody? Fast. What is the meaning of volatile gases? Volatile gases, highly evaporated gases. Okay. So aeration brings water and air in close contact. Wait, ma. Aeration brings water and air in close contact in order to remove dissolved gases such as carbon dioxide and oxidizes dissolves metals such as iron, hydrogen sulfide, and volatile organic chemicals. Oxygen is added to water through aeration and can increase the flappability of water by removing the flat taste. Okay, aeration. So what are the effects of aeration, anybody? What are the effects of aeration? On an aerated lawn, water penetrates more deeply into the soil, creating a deeper root system that is much more drought tolerant. If you have any irrigation system, this could reduce your water bill. If nature water your lawns, every rainfall will have a greater impact on your lawn. Okay. So what is the purpose of water aeration? What is the purpose of aeration? In industrial water conditioning one of the major objectives of aeration to remove the carbon dioxide and hydrogen sulfide harmful gases. Okay. So aeration is also used to oxidize the soluble iron manganese to insoluble precipitates. Aeration is often used to reduce carbon dioxide liberated by a treatment process. Okay. So all of you open your books and keep headings. Screening, aeration. And next step is aeration. What is the next step? After aeration, what is the next step?
Sedimentation.
Yes, sedimentation after coagulation. Okay. What is coagulation in wastewater treatment? Coagulation is a chemical water treatment process used to remove the solids from water. Okay, in sedimentation process, we remove 75% and remaining percent we have to remove, we can remove in coagulation process. Okay, by manipulating electrostatic charges of particles suspended in water. This process introduces small, highly charged particles, highly charged molecules into water to destabilize the charges on particles colloids or oily materials in suspensions. Okay, and remaining 25% by we can remove by using coagulation method. Okay. Why is chlorine added to water? This is overall potable drinking water steps. First step, screening, coagulation, flocculation, sedimentation, and last one is the filtration. Okay. So by seeing this picture, you can write your own words also. So just you have to remember the side headings. Side headings, what is the content also. Okay. You know, what are the coagulation? I mean, what are the types of coagulants? We used some chemicals here. You can observe like aluminum sulfate, okay, aluminum hydroxide. Some more coagulants also present. Okay, so those are ferric sulfate, ferrous sulfate, ferric chloride, and ferric chloride sulfate. Okay, so what are those? Ferric sulfate, ferrous sulfate, ferric, ferrous, ferric sulfate and ferrous sulfate, ferric chloride, and ferric chloride sulfate also include into the coagulants. Okay, what are natural coagulants? Anybody? Natural coagulants. It is obtained from naturally, means plants. Okay, so natural coagulants extracted from plants, algae, and animals. Okay, among these are polysaccharides and water soluble substances that act as coagulation and flocculation agents also. What is the best coagulant? Anybody? Ferric sulfate is the best coagulant. Okay, so it is works in a similar way to aluminum sulfate, and it is considered to be highly effective coagulant for industrial uses. Depending on the availability of ferric sulfate may be cheaper to source than aluminum sulfate or other aluminum based coagulant, although this may not be true in every location. Okay, so this is about potable water. In potable water we get we have steps. Okay, so all of you